Good morning, good afternoon, or good evening, depending on where you are in the world. My name is Sharon Florentine. Welcome to today's Security Boulevard webinar, Shifting Left, the Benefits of Implementing Security Throughout the Mobile App Dev Process, brought to you by GuardSquare. We have an awesome webinar for you today, but before we get started, I need to go through some housekeeping items with you. Please remember this session is being recorded, so if you miss any or all of it, you'll be able to go back and watch it again. We will send you an email with instructions for accessing the webinar on demand, or you can always visit us at securityboulevard.com/webinars, and it will be available there for you as well. We are taking questions throughout the presentation, so you can use the Q&A tab on your console to submit those at any time. We will try to get to as many as possible at the end of the presentation. There are a number of handouts available for you too under the Handouts tab. They deal with a lot of excellent GuardSquare products, so I would recommend you grab those for some reading after the event. Finally, stay tuned because we are doing a drawing for 4 $25 Amazon gift cards, so stick around to see if you are a winner. All right, before I introduce our excellent speakers today, they've asked me to push out this polling question for you just to see where everyone's at today. So you're going to see that pop up on your screen, and we would appreciate it if you could take a couple seconds and let us know, does your app have protections against reverse engineering? And your options here are no, I don't think I need it. No, but I want to have it. Yes, or yes, but I'm not sure if they are strong enough. So while we have that poll open and you all are graciously giving us your responses, I'm going to go ahead and introduce our speakers here today. We are joined by Jonas and Dario and from GuardSquare, and they are going to take you through this presentation about shifting left and hopefully be able to answer all of your questions. So let's leave this poll open for just another couple seconds, and I'm gonna turn it over to them and let them better introduce themselves and tell you a little bit about themselves. So let's go ahead and close that out. All right. And gentlemen, I'm going to turn my camera off and my microphone and let you take it away.
Thank you very much, Sharon, for the introduction. I'm Dario Dallefrate, and I work at GuardSquare as Product Marketing Manager. Today, I'm going to start this webinar, and I will be assisted during the webinar by Jonas, who will show you some demos relevant to the webinar. But before that, I'm going to start this seminar sharing a personal experience. I used to work in the UK, but I live in Belgium. Then every weekend I flew from Birmingham to Brussels back and forth. To save money, I bought flight tickets early in advance, and I tried to plan everything in advance, like having only hand luggage, no reserved seat, no priority boarding. But unfortunately, my cost-saving tactics sometimes failed. I forgot an event that required, for instance, a smart dress code, so I had more luggage to check in. And you know what? I ended up paying more than the original ticket price for my extra hold luggage. Similarly, regarding mobile security, mobile application security, quite a few organizations don't plan in advance. According to a recent research, only 35% of organizations have some kind of security best practices in place for mobile apps. Despite 85% companies saying that mobile app security is an important goal for their company and for the overall business strategy. And the company who have security best practices in place rely very often only on mobile app pen testing. That means that they find security issues late in the process, or when the apps are already released in the market with, you can imagine, huge remediation costs. In the best case scenarios, in fact, developers need to leave what they are doing. They have to go back to the source code of a previous release. They have to find and fix the issues. And, switching from current activity to all the ones is always very time consuming and above all, very expensive. IBM estimates that fixing issues when the app is released is up to 100 times more expensive than fixing an issue during the development. Overall, last year, 39% of organizations had a security incident involving mobile devices, and 2/3 of them, 66% of them, had a major impact on the organization. This is data according to a research done by Vison. The situation overall is not getting better. Security incidents are very likely to become more and more frequent, mainly for 2 reasons. According to CNBC, by 2025, the vast majority of internet users will access the web only from a mobile device. And moreover, the use of mobile apps skyrocketed during the last year. We spent plus 40% more average monthly hours on mobile apps, according to App Annie. So bad actors are very, very interested in attacking our apps. And there are quite a few reasons for them to attack mobile apps. First of all, they want, for instance, distribute premium apps for free. So they attack apps for fun in order to distribute them for free. And if you do a quick research with a web search engine using keywords like free premium apps, you will see quite a few third-party stores to download illicit apps. Another reason to attack apps is because bad actors want to steal money, and it's very likely to find financial or bank credential on your phone, on my phone. According to MasterCard, according to a research that they have done recently, 64% of online retail and e-commerce customers tried a new digital payment. And unfortunately, 1 out of 4 consumers experienced some kind of online fraud. So bad actors often repackage famous apps to distribute malware by using third-party stores. Alien is one of them. It keeps on spreading across mobile platforms. And another one that emerged in Europe in May is T-Bot. And those malware target specifically financial mobile app users. At last but not least, another reason why bad actors attack mobile apps is because they are interested in stealing some kind of app secrets, IP or sensitive data. And unfortunately, it's common to find unprotected apps exposing sensitive data. Security researcher, for instance, found recently that about 1,000 apps within the top 3,000 downloaded apps have common data leak vulnerabilities. For instance, passwords, API keys, IP addresses, email addresses, and other sensitive data can be found sitting in the code, exposed to the world, exposed to bad actors who can reverse engineer your mobile applications. Another example published in the news was that more than 100 million Android users had personal information exposed by 23 popular applications that were misconfigured. So basically, it means that they exposed the API keys to access cloud services where user data was stored. Maybe you think that this is only an issue related to Android apps, because the Android ecosystem is more open than iOS one. Unfortunately, it's not. Also, iOS applications are vulnerable in a similar way to Android applications. For instance, this year, a call recording app leaked the API keys, letting bad actors obtain sensitive data. It means call recording from the cloud storage. And that issue was discovered by reverse engineering the iOS mobile binary with tools that and techniques that are freely available on the internet, so accessible to anyone, basically. And this is not just a single case. Another recent research published by Wired discovered that about 7,000 iOS apps out of 47,000 that use cloud services to store application and user data were misconfigured, leaking sensitive information. So this is an issue also for iOS apps. Moreover, there are also third-party stores to download illegal iOS apps, basically hacked apps where license checks have been removed, and so premium apps are distributed by bad actors for free. And those stores are accessible easily by jailbreaking iPhones with tools available in the internet, again for free. And you can find these stores just making a quick web search with some keywords like free iOS premium apps. So also iOS system is under attack. So how can organizations improve their mobile security posture? A better approach, which is the focus of this webinar, is shifting security left. That is to say, implementing a comprehensive security tools earlier in the development process. And there are quite a few benefits of shifting left. In this slide, I'm summing up the top 3 benefits. First of all, lowering the cost of cybersecurity, solving issues during the development rather than when the app is already released in the market. And we have seen the difference in terms of cost. Fixing issues when the app is in the market is 100 times more expensive than fixing the issue during the development. Secondly, shifting left help streamline application security, making it easier to address issues without distracting developers from their main activity, that is app development rather than fixing security issues. And at the last but not least, shifting security left, so addressing security issues early in the development process, improve the collaboration between development teams and security teams. So let me show 3 key steps to progressively shift security left for mobile application, avoiding basically to react just when released apps are being attacked or just after a pen test. The first move to the left is to keep real-time visibility into the threat landscape when your applications are published. How can you do that? Basically, with 3 main steps. First of all, monitoring threats in real time using intuitive dashboards and custom alerts, so you can understand which version of your apps is under attack, where, in which geographic area, for instance, which operating system is used for by your app that is under attack. Then you can analyze further the threat data, and you can uncover how bad actors are attempting to compromise your app. For instance, are trying to run your app on a jailbroken device, and then they are using specific tools to tamper with your apps. This kind of information are priceless to understand how to improve the security posture of your organization. And at last but not least, with all the information collected, you can act and identifying, for instance, suspicious users and taking proper actions, or you can provide insights to your development team to improve the security of your app in further iterations and further releases. Let's see a demonstration, and I will give the word to Jonas for that.
Thank you very much, Dario. So let me share my screen. All right, normally it should be visible now. Is that the case?
Sure is. I can see
Thank
it.
you.
Yeah.
So for this first demo, I prepared a small sample application. It's this demo application, which is basically, well, with a bit of a poor UI design, a photo editing app. So you can just browse the images on your phone, add some effects to it, and save it back to the phone. The thing with this application is that it is designed in such a way, if you did not pay for a premium subscription, that it will print out a watermark on the picture when you try to save it, so to convince people to actually buy a subscription to this application. Now, I protected this application with Xguard, our code hardening tool to protect iOS applications, but I did something wrong in the configuration. When I was doing that, I accidentally configured the tool in such a way that it would only report back to Threatcast what actually happened on to the application, let's say, but I forgot to respond to it. So in the end, all attacks are still effective. So let's have a look at that. I can pick an image here from my gallery. I should then be able to add some effects to it. So let's see what we have. Just to make it very clear, I'll increase the brightness a lot so you can clearly see the difference with the original image. So once we're done here, we can save it to the film roll of the device again. And let's quickly verify that it indeed is saved and there are some watermarks printed on it. As an attacker, I can tamper with this in many ways. But for this demo, we are going to use a tool called Frida, which can perform inline function hooking and actually change the entire way the application behaves dynamically, so no resigning, for example, is required. The script I'm using to do that is shown here in the text editor on the top right corner of my screen. Not going to dive into too much details there, that's a bit out of scope for this demo. But let's take a look at the effects. So I'm going to run the script and launch the app again. And if everything goes well, Frida should attach to this application, which is currently the case. If I save it again, it will print out watermark removed, just as it mentions at the very end of my script. And if I now go back to the photo section, we see that the image is saved again, but now without any watermarks, and of course also without paying for the subscription. So as you can see, we did not defend against this at all because of a misconfiguration. However, if we would regularly check our tool Threadcast, we would notice that unusual behavior. So let me refresh the page here. And normally these new threads should come in. So let me go to the list view. I see it's not fully up to date yet. And here we detected the hook of exactly the watermarker draw text in image. So you can clearly see which function was hooked. You can see that it happened on an iPhone SE as well as the iOS version. And as you can see, that also matches what we mentioned in the script here. So this exact function is being hooked at the moment. So of course, at this moment in time, the app would actually already be released and we would need to publish an update that patches this vulnerability. And in the end, there might already be users that misuse the vulnerability. So it's not the best approach. And we should even shift more left, but more on that later on.
Thank you, Jonas. Let me take over again the presentation. Okay, hopefully you see my screen. So yes, as said by Jonas, we should move further security to the left. And the second step is the implementation of mobile application shielding. It means basically using techniques inside your apps to protect them from bad actors' attacks, like the one shown by Jonas. There are two main types of mobile application shielding, code obfuscation and anti-tampering, and I'm gonna show them in more details. According to OWASP, reverse engineering is one of the top 10 threats affecting mobile devices. Bad actors use the compilers tools to decode unprotected apps, understanding how they work, with the goal to tamper with them to steal IP, money, or user credential, or access for free premium features, like in the demo shown by Jonas. Code obfuscation includes a set of techniques like encryption of your code, removing metadata, renaming classes, variables, altering the code structure of your app without altering the user experience, removing debug information, with the goal to make it harder to reverse engineer your app. In addition to code obfuscation, there is anti-tampering techniques. According to WASP, tampering, in fact, is again one of the top 10 mobile threats. Bad actors use tools like Frida, shown by Jonas, or debuggers to change the behavior of your app while the app is running on a smartphone. To prevent that, runtime application self-protection provides a set of checks that are injected into your app to detect, for instance, jailbroken rooted devices, to detect tampering tools, debuggers, hook tools. Let's see again a demonstration. So it's your turn, Jonas.
Thank you. I will share my screen again. So while we would protect an application with Xguard to harden an iOS application, or with DexGuard to harden an Android application, for every run we make, a protection report like the one you can see open here will be generated. This protection report is, of course, only available to you offline. And we can see that this is the protection report corresponding to our demo app we were taking a look at in the previous demo. So this protection report will show you some KPI scores on how well the protection is applied to your application. This is just based on the configuration you have made, so this does not scan your app in any way. And it may provide you some very useful feedback on how you can improve that configuration and how you can therefore improve the hardening of your application even before you release it. So note that there is definitely some room for improvement possible here based on these KPI scores. And as you can see, also the issue I mentioned previously will be highlighted here. So our hooking checks or function integrity protection mechanisms, they are enabled, but besides monitoring, they are not doing anything at all at the moment. So this protection report allows you to shift a bit more left compared to Threatcast. Now you immediately have feedback even before publishing the application, and it's very easy to just rerun the tool at the moment with a modified configuration that does behave in the way you expect to be there, and you should not be publishing an update to your customers yet or be concerned about an older versions open in the wild.
Thank you, Jonas, for the demo. Let me share my screen again. Okay, hopefully you see my screen again. At this point, you might wonder why not implementing techniques like code obfuscation or anti-tampering on your own. Let's focus for a moment on the multi-layer protection. This is a well-known security concept. Back to the ancient time, medieval castle used that concept as well. Typically, around the castle, there is water to the first layer of protection. Then there are walls, an additional layer of protection, turrets, and lookout points to see attackers. And inside the walls, there is the keep, the main tower used as a last refuge in case of a siege. Imagine to build all these layers manually. That is time-consuming and an expensive process. You can do that, but it's really expensive. We build a castle automatically for you, adding several layers of protection to your apps, making it harder for bad actors, reverse engineer and tamper with your application. Moreover, if you follow a do-yourself approach, you have to change manually all security protections anytime you release a new version of your app. in order to make it harder for bad actors to attack your app. We do that automatically. We call that polymorphism. It means basically that we change all the protections every time you release a new version of your app. Basically, it means that you reset the clock of attackers because they need to start the attack from scratch. At the last but not least, apps nowadays need to run on different platforms. With a do-it-yourself approach, you need to maintain different codes for the same security functions, and that is expensive. We use a uniform approach, regardless the platform and the programming languages used to create apps. So again, that is a good reason to use those kind of tools rather than doing a do-it-yourself approach. Now let's talk about an additional step to move security left, the last step. And the last step is integrating mobile application security testing earlier in your development process with developer-friendly tools. I mean tools built for developers and designed specifically to target mobile applications, to keep checking the security of your apps while you are developing them. Ideally, these tools integrate easily with IDEs familiar to your development team, and they integrate easily also with your CI workflow. Ideally, this tool don't distract the developers too much from their main activity, which is developing the app. So these tools focus more on real issues, real security issues. And at last but not least, these tools provide actionable recommendations in order to fix quickly the security issues identified by them. And we have developed such a tool. It's called AppSweep. So let's see a quick demo. Jonas, it's your turn.
Thank you, Dario. Once more, I will share my screen with the audience to demonstrate AppSweep. So, of course, when it comes to mobile security, there's more to it than just applying code hardening. While code hardening can perfectly cover up a certain API key, a cryptographic key, or maybe the intellectual property of a certain algorithm you have in the application, there are vulnerabilities that you tackle better in a different way than just trying to cover it up. Vulnerabilities that are really existing on the code level. Think about using the wrong type of cryptography. So for that, we have this free tool available called AppSweep. Currently, it only works for Android applications, and you can either upload your application to the website here, the APK that is, or you can choose to really integrate it in your Gradle setup so that you get feedback for every build you make and thus again shift left. So here on this website, there is a demo available. It's publicly available should anyone want to have a better look at it after this webinar. And as you can see, here you can see the different builds of this demo application. And if you click on one of these builds, you will be directed to a page that gives you an overview on what types of vulnerabilities we found into this application. So you can see that they are ordered in different categories from a high severity to a lower severity. And of course, it's important to fix these vulnerabilities as early in the development as possible. You definitely will not want to fix these after the app actually already had been released. So I would definitely recommend to check out this tool. So Dario, I would like to pass the word back to you.
Thank you, Jonas, for the demo. Let me switch to the presentation again. Okay, hopefully you see my presentation again. So before finishing this webinar, I would like to show you some case histories. A leading video software company that has created an app used by Hollywood and Bollywood movie producer had a big security threat. They came to us because they have a freemium app, and the premium app has been hacked and distributed for free on third-party stores. And that issue has become very relevant to a point that about 40% of users were using the hacked app instead of the original one. So you can imagine the impact in terms of revenue loss. This company deployed a GuardSquare solution, specifically the XGuard for Android, to obfuscate, encrypt, and apply runtime protection, runtime self-protection. That was extremely important for them to protect their IP, to protect their application secrets, preventing bad actors to break into the app, removing, for instance, the license check, and redistribute the hacked app for free on third-party stores. We work also with financial institutions, and for instance, a leading mobile payment app SDK company had the need to fulfill very strict compliance requirements, you can imagine, for mobile payments like PCI. At the same time, they wanted also to offer the most secure product for their customers. That means having in place techniques for jailbreak, root detection, debugger detection, and integrity check of their SDK. The security team selected GuardSquare solutions both for Android and iOS SDK for hardening their mobile payment SDK. The tools were deployed to make the company's product obfuscated and encrypted. So it's now harder for an attacker to break into the SDK, reverse engineer the SDK, read its code, and tamper with the SDK in order to do malicious activities like steal money. So in this webinar, we have discussed about several topics, what we have learned today. We have seen that bad actors are very interested in attacking mobile apps, mainly for fun or to steal money, to steal IP, and or just to harvest user credentials for other attacks. We have seen that Android and iOS apps are both under attack. Both mobile operating systems are vulnerable. A way to reduce cybersecurity cost is to address security issues earlier in the development process. We called that approach shifting security left. And in particular, we have seen 3 steps that you can take progressively to shift more and more security left. First of all, using real-time threat monitoring tools to keep an eye on the threat landscape affecting your apps when they are in the field. Then using insights coming from those tools to improve mobile application protection, even using a combination of techniques, code obfuscation and anti-tampering techniques. And at last but not least, to shift even farther to the left, your security, you can integrate mobile application security testing in your development process. So in this webinar, we have seen real tools in action, thanks to Jonas, and we have seen also some customer stories. Thank you for your attention.
All right, that was fantastic. Thank you so much. All right, so it is time to start digging into some of these awesome audience questions that we've gotten. I'm going to start with this one. Does your solution protect app extensions?
I believe that's a question I would be able to answer. Yes, we do. So we can protect an app extension as part of an iOS app as long as it's part of the IPA. The same would go with a watch app, for example, that is embedded on Android. We would be able to do the same.
Cool, thank you. All right, so how can code obfuscation protect me? Me meaning the audience member that asked the question, not me in particular.
I'll take this question as well. So code obfuscation on itself will not be able to protect you from getting hooked, like we've shown in the first demo. We could try to hide security sensitive functionalities into your application, and it might take the attacker a bit more time to discover what he actually wants to hook, but in the end, it's not a good protection. And that's exactly the reason why our tools will not only apply code obfuscation, but on top of that, they're also capable of inserting checks, these runtime application self-protection checks, that actually can do that. It can detect not only that your application is hooked, but as you could see in the first demo, also which function was hooked. In that example, it was a function that draw a watermark to an image. So you actually see what's interesting towards attackers to modify. And if you want to also respond to that, which would be very recommended in contrast to what we did in these demos, you most likely want to make the application crash in a random way as soon as that threat would be detected. Hence, the application would not longer be useful towards the attacker.
Okay. So let's see, how do your solutions integrate into a CICD system like Jenkins, for instance?
It depends a bit on what solution we are talking about. So for DexGuard and AppSweep, both have a Gradle plugin available, so you can easily integrate it in your Gradle setup, and therefore it would also be invoked as soon as it's part of a CI/CD system. You can make DexGuard part of the repository or use our Maven repository instead. When it comes to XGuard, that would be available as a command line tool. It's just one command that you can invoke, and it's typically always the same command, so you can easily add it to the post-build script of your CI/CD system.
Let's see, what else do we have? If I build the security application, can I use the same app across Android, iOS, and Windows phone devices?
I'm not sure I understand that question entirely correct, so please feel free to elaborate should this not be a full response to your question. There are indeed certain hybrid frameworks that allow you to develop apps for these three platforms altogether. Think about, for example, on Cordova, Ionic, React Native. And we can indeed protect these applications for Android and iOS. Our tools, or we do not offer you any tools, unfortunately, for Windows Phone. But the configuration you make, it's on for iOS on the bitcode level and for Android on the Java bytecode level. So they would differ between the two apps. So the configuration will be different for Android compared to iOS. So it's not one solution will fit all here.
Okay. Hopefully that answered your question. If not, feel free to elaborate and send that over, and we'll get that answered as well. All right, next up, how long does it take to implement GuardSquare solutions?
I can take this one.
Okay.
It doesn't take a lot of time to implement a GuardSquare solution. Typically, you can implement GuardSquare solution within a sprint, and it means from 2 weeks to 4 weeks, depending on your planning.
Okay, yeah, that's not very long at all. Okay, how can we protect sensitive customer data, for instance, credit card processing? I think this, I'm not sure who to direct this to.
Well, I'll try to answer the question as well as possible. So when it comes to processing credit card information, there is, of course, not a one-stop shop solution that can protect that one functionality in all different areas. You might want to have some security mechanisms on the network layer, on the server side, as well as your application. As far as our solutions go, we can only help you protect against the reverse engineering aspect. So also, please note, I would be lying if I would say that it's possible to completely prevent reverse engineering. That no one can guarantee, but we will raise the bar here and we will make it more difficult for reverse engineers to understand how your app works under the hood. And it can also be quite important for your backend, because some attackers prefer to have a look underneath the hood of your application first to extract some API endpoints, for example, to perform a man-in-the-middle attack on their own device to see what information you're passing, and therefore get a better understanding how stuff is working, which they can then leverage towards an attack on one of your servers.
Okay. And if my customer data is secure, isn't that all that matters?
I can answer this, where it really depends on your app. In some case, the answer is yes. In other case, if you have other sensitive information, like for instance, proprietary algorithm, or you have in-app payment systems, that is not enough to protect customer data only. You need a multi-layer approach to protect also this kind of app secrets.
Okay. And finally, how many programming languages does your solution support in the mobile domain?
I can answer this as well. We support both native applications and hybrid applications. Jonas has already answered about that. Native applications, it means that we support applications written in Java, Kotlin for Android, Objective-C, Swift for iOS. We support also native code libraries, so written in C, C++. And we support also hybrid application written with frameworks like Cordova, Ionic, Reactive, React Native, as said by Jonas.
All right. Well, thank you both so very much. Thank you, folks, for all those great questions. All right, just a reminder that the session has been recorded, so if you missed any or all of it, you'll be able to go back and watch it again. We will send you an email with instructions for accessing the webinar on demand, or you can always visit us at securityboulevard.com/webinars, and it will be there for you as well. All right, so it is now time to draw the winners of our Amazon gift cards today. And our first winner is Matt R. Congratulations, Matt. Our next winner is Tan M. Congratulations. Our third winner is Brian K. Congratulations to you. And finally, Ron K. Congratulations to all our Amazon gift card winners. We will send you a separate email with instructions for claiming your gift card, so keep an eye on your inbox for that. And if you don't see it, please make sure to check your spam folders. Folks, don't forget there's a bunch of great handouts available there on the Handouts tab in your console, so go ahead and grab those. Some really good information there. Thank you all so very much for attending. Thank you, Dario and Jonas, for the amazing presentation and demos. And we hope to see everyone again at another Security Boulevard webinar soon. With that, I am Sharon Florentine, signing off.
Thank you, Sharon. Thank you, everyone.
Thank you. Enjoy your days.